Hi guys, welcome back to In Case of Econ Struggles. Welcome to another AP Micro Struggle. Today I'm talking about topic 3.3, which is the long run cost function. So today we're going to talk about those short run curves that we talked about last time. We're just going to talk about them in the long run. We're also going to talk about a couple properties of cost functions in the long run. So here are the things the College Board wants you to know for the AP exam about long run cost functions. So first, we're going to learn about something called economies of scale, and I'm going to talk about a trick for Cobb-Douglas when it talks about economies or returns to scale, talk about the long-run average total cost curve, talk about something called minimum efficient scale, and then the thing to remember about long-run is that all inputs are fixed. And the thing to remember about the long run is all your inputs are variable. So in the example of Bill's ice cream, we said he couldn't change the number of ice cream machines, the number of buildings in the short run, but in the long run he can. And the fact that he can do that sort of drives this whole notion of a long run average total cost curve, minimum efficient scale, and economies of scale. So let's just get into this economies of scale, where we're going to talk about production functions. So the question that you want to answer is, if I double the amount of workers that Bill has, if I double the amount of ice cream machines, what happens to Bill's output? Can he more than double the output, in which case we would say he has increase in returns to scale. So when he sizes up, he gets even more efficient. Does he get exactly twice the output when he doubles his inputs? That would be constant. So that would say Bill has one worker and one machine and he can make 2 ice creams. Then if Bill had 2 workers and 2 machines, we would say he can probably make 4 ice creams. And if you doubled it again, he could make 8 ice creams. If you doubled it again, he could make 16 ice creams, on and on and on. But basically, anytime that Bill doubles his inputs, he just doubles his outputs. Now, if you can't quite get to that state, if you have less than twice your output, we say you have decreasing returns to scale. So for example, here's a basic production function. Here's 2L plus 4K. So this would say something like, if Bill had 1 worker and 4 machines, he could make 6 ice creams. So we're asking, what happens if Bill had 4 workers and 8 machines? Could he make, 16 ice creams? I don't know. Let's find out. So here we're just going to double the amount of machines and double the amount of workers. So I'm just doubling and doubling here, which is going to give me 4L plus 8K, which is just twice my original function. Here's my original function f right here, which just says that I have constant returns to scale because I doubled my output. Now it's unclear if this is going to be on the AP exam or not, but it might be, and this might help you. You have a very special production function, which is Cobb-Douglas. It looks like this, L to the alpha, K to the beta, which means that it could be something like, L to the 4th, K to the 3rd, or it could be L to the 2nd, K to the 3rd, could be L to the 0.1, K to the 0.5, something like that. Now what you're going to do is you're going to take these 2 exponents and you're just going to add them together. And you're going to ask yourself, is it greater, equal, or less than 1? Greater than 1, you have increasing returns to scale. Equal to 1, you have constant returns to scale. Less than 1, you have decreasing returns to scale. And you can very easily tell what sort of scale your production function has just looking at those exponents on your L and K. Now let's take a second and sort of break down this sort of intimidating looking graph. And all I'm trying to do with this graph is to say that the long run average total cost curve, you have a bunch of short run average total cost curves, which we talked about last time. The long run average total cost, you're just going to trace out the bottom, the minimum of those short run average total cost curves. So for example, you start here and you say, okay, I'm going to do something like this. And then I'm not going to continue. I'm not going to keep going because there's a cost curve that is lower than this curve, which is this guy right here. So what's going to happen is I'm going to come up like this, and then I'm going to switch to the second short run average total cost curve, and then I'm going to switch to this third average total cost curve, and then this fourth average total cost curve. Now, what are all of these short run average total cost curves representing? Well, remember in the short run, we're fixing the number of ice cream machines that Bill can have. So this is the short run average total cost when Bill has 1 ice cream machine, 2 ice cream machines, 3 ice cream machines, and 4 ice cream machines. On the x-axis, we have the number of ice cream cones that Bill is trying to make, and this is just cost or dollars. So what this would say is that when Bill is over here trying to make this many amount of ice creams, he has 1 ice cream machine. As soon as he gets to this point, he adds a second ice cream machine, so he's on this new short run average total cost curve. Then he produces out here and he says, okay, it's time for a 3rd ice cream machine. And then he gets over here and says, okay, now it's time for a 4th ice cream machine. And that's how Bill makes his decisions about how many ice cream machines he needs based on the number of ice cream cones that Bill wants to make. Now that that makes sense, let's break down the regions of this graph. So notice that on this side, and the reason I've sort of traced out this general shape right here is because you can imagine that in this world, Bill can have any number of ice cream machines. It doesn't have to be 1, 2, 3, or 4. So if I drew the infinitely many short-run average total cost curves, you can see that the general shape of the long-run average total cost curve would be something like this big elongated U shape right here. So let's dive into this further. You can see on this first part that the long-run average total cost curve is falling, which means that as Bill is scaling up, his average total cost curve is decreasing. And we call that economies of scale because when Bill's average total cost in the long run is falling, that's called economies of scale. Now, once it gets to about here, his average total cost curve is flat. That's what we call the efficient scale because his average total cost is constant as he's making more ice cream machines. So the point at which Bill's long run average total cost goes from falling to flat, that's what we call the minimum efficient scale. That is the lowest number of ice cream cones that Bill needs to make in order for his average total cost curve to be at the minimum and constant. Bill gets excited. Maybe Bill wants to make a lot of ice cream cones, and he starts to make so many ice cream cones that his average total cost curve, even in the long run, starts to creep back up. That's what we call diseconomies of scale because his long run average total cost curve is going up. And that means that Bill is probably making too many ice cream cones, and he could do better if he goes back and makes less ice cream cones. So this point right here, sort of the maximum number of ice cream cones that it makes sense for Bill to make. Again, we're going to talk about this way more when we talk about profit maximization, but hopefully you're just getting an idea roughly of how we're going to do sort of this analysis in order to answer the question, how many ice cream cones should Bill actually make? That's where we're going. That's what we're trying to set up with all these cost functions. And hopefully this long run average total cost curve, A, makes sense, and B, will help you understand how we're going to get there. So comment below if you have any questions or there is something you didn't understand. But if this was helpful, make sure to like and subscribe, and we will see you next time for another case of econ struggles.